let's talk about the first validation technique, which is called Z-test. And again, guys, all these tests that we are studying, they have their own peculiar features. So as and when we proceed in the class, we'll be talking about those features also, so that when you are solving a particular question, you will be in a state to identify that, okay, on this question, I should be using Z-test and nothing else. So that clarity you will have. Okay. So first of all, Z-test, what is the formula for Z-test? Simple formula. Z-test can be given as sample mean, that means your X bar, yes, minus mu whole divided by standard error. SE is standard error. How do we calculate standard error? Standard error is given as standard deviation of sample, standard deviation of sample that you are using in the question. Okay, standard deviation of sample whole divided by under root of sample size, which is small n. So standard deviation divided by under root of sample size is what we calculate as standard error. Once we have the standard error, we can replace it here in the denominator and we will be able to calculate the value of Z-test. Okay. Let us see this with the help of an example. Let's say I'm giving you an example here, and then you guys can solve a question also. So yesterday, while discussing about rejection region, I told you people that rejection region, when we are creating, we need to have a specific value over there. So that specific value we can generate using these techniques, Z-test, T-test, all those things. So let me write down the question here. The question says, one more thing. The way how I have shared the booklet for Python, in the same way, you people will also get a small booklet with respect to statistics. Okay, University of Sydney. It's a resource material of University of Sydney. Pretty good resource material it is. Not very advanced, not very basic, kind of moderate, which we usually want to have, and you can make use of it. So maybe by today, tomorrow, within the next 2-3 days, I'll be sharing it. Okay, so you can keep that also as reference material. However, all those things which we are covering here are more than sufficient. You don't need to read anything extra as far as data science is concerned. But still, if you wish, you can give a read to that concept. So let's say the question is a company, a printer company claims that one cartridge can print 500 pages on an average. Okay, a printer company claims that one cartridge can print 500 pages on an average. Print at least. Okay, print at least 500 pages on an average. Now, what do? We choose a sample of 100 printers, and we found that what should we take? And we found that around, or not around, 490 plus minus 30 pages were getting printed on an average. by one cartridge, right? This is what you have. Now, the question for you is, considering 95 or should I take 95? Let's consider considering 95% of confidence. Considering 95% of confidence, developed H0 and H1. Sorry, H0 and H1. Develop H0 and H1 and validate the result. Something like this. Okay. This is the question which you have. We shall see how we solve this using Z-test. I think the question is very clear. The printer company claims that one cartridge can print at least 500 pages. Yes. So what is this 500 pages? What is this value?
Null, even you're talking about hypothesis, or
Right. So this is the average, na? So we can consider it to be population average. This is the population average because on a whole it is saying this. So this 500 pages is your mu value. Because see, what do we have to find? Where is the formula? This is the formula, na? So we need to identify X bar, we need to identify mu, we need to identify small n, we need to identify standard deviation. All these things we have to calculate. So considering the question, this 500 pages which we have is the population mean. So I will consider it to be mu. Here it says sample of 100 printers were chosen. So what is this? Small n?
sample size. Yeah.
Sample size, small n. And what did we find? Based on the sample, we found 490 plus minus 30 pages. So this is what? This is with respect to the sample. So that means this 490 is nothing but your X bar, isn't it? Because it is with respect to the sample. It is with respect to the sample. That's why 490 is your X bar. What about this 30? This 30 is your standard deviation. Okay. Why? Why is it your standard deviation? Because it talks about the spread of the data. So 490 plus 30 or 490 minus 30. So the dispersion, it is talking about the dispersion. So that is why 30 is your standard deviation. Because we know that standard deviation and variance, they are interrelated. Variance, if we do a square root of variance, we get standard deviation. Yes. And what is the basis of your variance? The dispersion component only. Yesterday, I think we were discussing about that. Dispersion is high, that means variance is high. Dispersion is low, means variance is low. All those things we were talking about that. So 30 is your standard deviation. And then here, what do we find? 95% of confidence we have. That means alpha will be how much? 5%.
Yes.
Alpha will be 5%. We have to develop H0, H1, and then we have to validate the result. Fine. So let us use this formula and let us write down the components which are available to us. Achha, before that, before I go to Z-test, can you people tell me what will be H0 and what will be H1? This is something that we did yesterday. I think you can give it a try.
H0 is equal to 500 pages.
So I can say H0 average is equal to 500.
Yeah.
Average pages, I can say average pages equal to 500.
Yeah.
Pakka? Sure.
Because it's a company that is claiming, no? So I think what they're claiming, at least, is it less than or equal to?
Yes, correct. Now it's right.
Sorry, I missed that part, at least, less than or equal to, yeah.
So H0 will be average number of pages that we have, average pages that we have will be less than equal to 500. Sorry, not less than, na? At least कम से कम 500, मतलब 500 या 500 से ज्यादा, 500 or more than 500. So not less than, greater
So
than.
must be equal, great, at least, yeah, greater than or equal to, okay. Yeah.
Greater than equal to 500. This is your H0. What is H1? The alternate of it. So average page, average number of pages,
Less than 500.
less than 500, because we just have one condition. So because we have just one condition in H1, this is one tail test.
Yeah.
This is one tail test. This is a one tail test. Now, let us quickly draw that diagram which we learned yesterday. Let's say this is 500 pages, 500 or more than that. Let's say 600, let's say 700, something like that. So this is what? This is the claim of the company. So this is H0. We don't want that to happen. So where will we go? Left side. We want to reject H0, na? So we will go on the left side. So what is this? This is a left tail test. Agree?
Yeah.
Left tail test. Fine. So in the left side, you will have 400, maybe 300, 200, all those values you have. Okay. Now what do we do is, we have all these values. We have identified that it is a one-tail test. So if it is a one-tail test, we will keep alpha as it is. Yes, we will keep alpha as it is. So I will say alpha is equal to 5% only. I don't have to divide it as such. It is not a two-tailed test, so I will not divide it as such. I will simply keep alpha as it is. Now, after doing all these things, now let's get into the Z test. So what are the values given to us in the question? Mu is given how much? 500. X bar is given how much? 490. Standard deviation is given how much? 30. Sample size is how much? I think 100. And then alpha is also known to us. It's 5%. So you can either keep it in percentage or you can simply divide it by 100. You can say alpha is nothing but 0.05. We are not dividing alpha by 2 because it is a one-tailed test. Okay. Now, based on these values, can we calculate standard error? Yes. What is the formula of standard error? Standard deviation divided by under root of small n. Yes, under root of small n. So standard deviation is how much? 30 divided by under root of 100. That means 30 by 10. Standard error is how much? 3. Okay. Is this part clear? Standard error is 3.
Yeah.
Okay. Fine. Okay. So now we have calculated standard error and that is equal to 3. Then what do? We will calculate the Z test value. Z test value from where? From the data given to you. So I will say Z test is equal to, what is the formula? X bar minus mu. You can just verify. X bar minus mu. So X bar minus mu by standard error. What is X bar? 490. 490 minus 500 whole divided by 3. So the value of Z test that we have from the data given to us is how much? Minus 10 by 3 or minus 3.33.
Yeah.
This is one value that you have to remember for the time being. So what happened to this thing? Give me a minute. So this value which we have, Z test value, which we have calculated as minus 3.33, is something that we have to remember for the time being. We need to remember this value. Okay. We will have to remember this value for the time being. Okay, fine, no problem. Now what we will do is, we know that we have level of significance as 0.05. A level of significance we have as 0.05. So considering this level of significance, we will calculate Z. Again, we will calculate Z. This time we calculated Z for the data given to us in the question. That's why it's called Z test. Fine. But the value of Z that we are going to calculate now, for that we will be using Z table. If you can recall, yesterday I was mentioning this. So Z of 0.05 is something which we are going to calculate. Okay. Z of 0.05 is something which we are going to calculate. What is 0.05? Nothing but your level of significance. So in order to calculate that, what we will do, we will take assistance of the Z table. So let's quickly go to the Z table. We can go to Google and we can search for Z table. So I did not share the screen, just a second. Okay. So you can either download this table if you want. Right now, you guys will be solving one question. So if you want, I can share this table. I can download it and I can share it with you people in the chat box. Otherwise, you can simply access it from the internet also. It's available readily. Okay. So this Z table that you see in front of your screen, how do you read this table? How do you read this table? Very simple. On the x-axis or on the horizontal axis, the values which are mentioned like 0.00, 0.01, 0.02, all these values which are mentioned, these values are nothing but level of significance. Okay, these are the level of significance alpha values mentioned on the horizontal axis. Whereas if we look at the values mentioned here, minus 3.9, minus 3.8, all these values which you see is what? It is the value of Z test. Z test from the table. Sorry, Z test from the data which is there with you. So for us, what is the value? Minus 3.3. If you can recall, right now we calculated Z test value, minus 3.3. What is the alpha value? 0.05. So let's make an intersection, minus 3.3 and minus 3.3 and 0.05. So what is the intersection? 0.00040. Is this point clear? How we are able to identify?
I'm good. Yeah, I'm good.
I'm sorry. Could you, I understood the intersection point, but how do you take these values of minus 3.3 and 0.05?
Yeah, so in the y-axis, I'll just write here just a second. On the, when you are reading this table, Z table, on the x-axis, you will have to look into the values which are your alpha values. And on the y-axis, you have to look for the values of Z test.
Okay.
This is the way how you read it. Now, from the question that we have just solved, we have, just consider this. We have alpha value as 0.05.
Okay.
Yes. And Z test value we have calculated as minus 3.63.
3.33. Okay. Yeah.
So
I.
same values.
Yep.
In the x-axis, we will search for alpha as 0.05.
Yeah. And Z
And
we
here,
got it as 3.33. Yeah.
wherever you will find the intersection, that becomes your Z test value from the data or from the table rather.
Got it. Got it.
So for us, from the table, the value which we got is 0.00040.
Okay. And will it be at times like way we would be having the Z text value and we would be required to find the value for alpha?
You can have that, but I personally have not inquired such questions.
Okay.
You can develop that question, it's possible, but
Okay.
personally never witnessed those questions.
Okay.
So two things we have right now: Z test value from the data given to us in the question and Z of 0.05, which we have devised from where? From the table, from the Z table. Now these two values are very important for us for further discussions. Why? Because this value which you have now, this value marks the beginning of rejection region. Okay, this value marks the beginning of rejection region. If you can recall yesterday's class, over there I was kind of drawing yellow points. Yes, I was drawing kind of yellow points, and I told you that as of now, just give me 2 minutes, guys. I'll be back. 2 minutes.
So Divakar, this.
Yeah. Yes,
Yeah.
Satish. Oh.
Yes, Ash. So Ashta, if you don't mind, I just trying to understand. So when you say beginning of rejection region, in the sense these zeros are after the point, right?
No. This entire value. Actually,
Entire.
let me show you. Just give me a second. Let me show you yesterday's
Okay.
notes.
I'm sorry. Ash.
Yeah, that's fine. No problem. That's 3. This one. Let me share my screen once. So this is what we were talking about yesterday. So as of now, we have understood that it is a one-tailed test, specifically what? A left-tailed test. Yes, so this diagram is applicable for us. This particular diagram is applicable for us. So what do we find here? We find that in case of this diagram, there is a rejection region here. Yes, you can see there is a rejection region. The red shaded area is the rejection region. So there should be a point, there should be a coordinate from where the rejection region starts, which I have highlighted as yellow point. So this yellow point is nothing but 0.00040.
Got it.
So that is the point from where our rejection region starts. So beginning of rejection region. That means if I'm drawing a bell-shaped curve here, just a second. if I'm drawing a bell-shaped curve here, okay, bell-shaped curve we have created, and we know that it is a left tail test. Yes, left tail test. That means rejection region will lie in the left side of the diagram. Okay. So as per the Z table, it suggests that beginning of rejection region will start from where? From 0.00040 mark. That means it will be very close to this point. Let's say this is 0. So this is 0.00040, right? So from here onwards, let me use a different color. From here onwards, from 0.00040, your rejection region starts. That means this entire part of your graph is under rejection region. That means the value of H0 which you have calculated, if it lies in this region, is in this complete region, if your value of H0 lies, then you are going to reject it. Then you are going to reject the claim of the printing company as such. So this entire part of the graph which you can see, this is your rejection region. This entire part is your rejection region. From where it is starting? It starts from 0.00040. Okay. And what is the value of H0? This gives you the value of H0. That means when we calculate Z test and when we say Z test is minus 3.33, this is nothing but value of H0. Now, what have we understood? Value of H0 is minus 3.33, means somewhere here, minus 3.33. So what do you think? Is it part of your rejection region or not? Definitely it is. Yes, definitely it is. It is inside this rejection region. So when H0 is inside the rejection region, because rejection region starts from where? From 0.00040. And why on the left side? Because it is a left tail test. How do you know that? We have calculated it right now. Yes, left tail test. So rejection region from 0.00040 towards the left side. Towards the left side. This is what rejection region is. And what is the value of H0? Minus 3.33. So obviously it falls under the rejection region. And that is why, because value of H0 lies inside the rejection region, what can we say? What can we say? We can say that we are going to reject H0. We are going to reject H0. And when we say we are going to reject H0, that means this entire claim of the company is going to get rejected. This company is lying. This company is making false promises. This company is not giving you authentic information. So you need to discard this particular offer. Is it clear?
Yeah, it's clear. Ashutosh, just one question. With the normal distribution you just drew, the bell-shaped curve, and if you scroll up and you are showing the values, the actual, yeah, that one, the green bit. So in the normal distribution curve, aren't we supposed to show these values and then reject the null hypothesis? Because they're claiming at least 500 pages, but then we know now based on the test that it's not the case, so we reject it. Because we found that it says 490 plus or minus, means obviously it's not. So my question is, are we using these figures to draw the bell-shaped curve?
These figures are only like important for us to develop this Z test.
Okay.
If you look into the formula, 490 you are saying, so 490 is being utilized here. 500 you are saying 500 is being utilized.
Right.
So
right. Okay.
these values which we have, they are actually helping us to calculate the value of H0. So they are being used.
Yeah. Okay.
We are not explicitly drawing them here in the graph, but they are being used.
So Z test estimated calculated value is nothing but H naught value.
Mhm.
Okay.
So this is the place from where rejection starts. I just wanted to represent it properly. So this entire area from here onwards is your rejection region, and this falls under that rejection region only. Minus 3.33. It falls under that area only. So this is how simply you can use Z-test value for validating that whether the claim of the company is right or wrong. And based on that, you can try to collaborate with the company if they're saying something authentic, if they're making correct promises, if they're true with their intentions and with their words, then you can definitely collaborate with them. Otherwise, you can refrain from doing that. Okay. So this is what Z-test is all about. I think it's clear. If you have any questions, I'll just write down the final inference which we have. So I'll just write down, since H naught lies in the rejection region, we will reject H naught. We will reject H naught. And when we reject H naught, what happens? We will reject H naught. That means the claim of the company is wrong. They are making false promises. All these things you can write down by yourself. We reject H naught. This is the final inference.
Does that mean we accept alternative hypothesis?
Yes, we accept alternate hypothesis.
Okay.
But usually we don't say that. We either say that we reject H naught or we accept H naught.
Yeah. Okay.
So this was one example. I'll give you one question right now, but prior to that, just tell me if this example is very clear. We have to first of all look into the steps. So if you look at the entire question that we have solved, over there are few steps that we have followed. What are the steps? First of all, we have developed H0 and H1. Then we have calculated whether it is a one-tailed test or a two-tailed test. Then depending upon that, we have understood that whether alpha is supposed to be considered as alpha itself or whether we need to change that value, right? Whether we have to divide it. So this inference we have made, then we have understood that because it is a one-tailed test, so is it supposed to be left tail or right tail? That is something which we identified. And then we calculated Z test value, then Z values from the table. Then we made a comparison and the job is done. Clear? This example, guys, is it clear?
Yeah, it's clear to me. I'm good.
Okay.
Yeah, I'm good. I'm good, Ashutosh.
Fine. So this is what Z-test has to do. One more question I'm giving you people. Give it a try. And then we shall move to the next test. How much time do we have? Yeah, we have some good time. At least t-test we will be able to complete. If not chi-square, at least t-test definitely will be completed. So just if you guys can give me 2 minutes, I'll bring a question from the, instead of me writing down questions, it's better if I give you questions directly from the book. So just give me a minute. Hypothesis. because that will be more authentic. Okay, so this is the question which we have. Just read this question once and then you can start solving. So it says a company used a specific brand of tube lights in the past, which has average life of 1000 hours. A new brand has approached the company with new tube lights with same power at a lower price. The sample of 120 light bulbs were chosen for testing, which yielded an average of 1010 hours with standard deviation of 90. Matlab 1010 hours plus minus 90. Should the company give contract to this new company at a 1% significance level? So I told you yesterday, either they will mention directly the significance level, the way they have done here, or they will give you confidence confidence level, and then they will ask you to calculate it from there. So both the ways, you know how to approach. So here you have level of significance directly mentioned as 1% or 0.01 alpha value. Okay. So keeping this pattern in mind, you have to solve this question. So first of all, you have to develop H0 and H1 and then go on with the same speed, with the same process, same steps. Okay, give it a try.
Ashutosh, you there?
Yeah.
So with the hypothesis, sorry, the null hypothesis, an average life of 1,000 hours is equal to H not equal to 1,000 hours.
Okay.
And then the alternative hypothesis H1, because it says an average, we can also safely say equal to.
So more than
1,000
that or less than that? Yeah.
more than 1,000 hours, you mean?
Yeah. So both of them will be valid.
Equal
Either
to is also,
because here it says average life is 1,000 hours. In the question it
that's
says average life is 1,000 hours.
so H
So
not
average,
equals 1,000 hours.
that means H1 will not be equal to 1,000. Right.
Will not be equal to. Yeah. Okay.
Yesterday we did that, no?
Yeah, got it. Yeah, okay.
So not equal to means greater than 1,000 or less than 1,000, both cases.
Oh, I see.
Otherwise, if you people want, I can just modify this. I can say average life of at least 1,000 hours. Then I think it will be
No, let's try this one. That's okay. It's all good.
this way, at least 1,000. Then you can develop H0 and H1 easily. Try it out.
So in that case, H0 becomes greater than or equal to
Greater than
1,000.
or equal to
And then
1,000.
and
H1
then
becomes
the
less than 1,000.
less than a
Less than 1,000.
less than 1,000. Okay. Yeah, so I think shall I have a go? I think I've done it.
Yeah,
So,
definitely.
okay, so as discussed, the H0
Hmm.
is greater than or equal to 1,000 hours, and then alternative H1 is less than 1,000 hours, right? That's the hypothesis. And I
Yeah.
think it is a one-tailed test as well. And I think it is a right side one-tailed test.
अच्छा ठीक है. Okay, I'll have to verify that. ठीक है, fine. Let's
And
consider
then the z-test calculated value is 1.217161, something like that.
Okay.
And then the value of z from the table for 1% significance is 0.88686. So obviously we will reject null hypothesis on this basis, but I think it's on the right hand side.
Okay, fine, no problem. So let me just quickly solve this, then we shall be able to verify.
Compare, yeah. If I made any mistakes, I can correct, yeah.
But I think it's right. Both the values which you are saying 1.21 and then 0.88, these values are right. So just a second, let's do it. So for us, H0 will be average life greater than equal to 1,000 hours, and H1 will be average life less than 1,000 hours. Obviously, it is a one-tailed test. Now, let us see what sort of one-tailed test, left or right. So let's say 1,000 is here, and we are saying that more than 1,000. So average life greater than equal to 1,000. That means 1,000, let's say 1,100, let's say 1,200, something like that. So this is part of what? H0.
Right, H0.
If we wish to reject H0, what we will do? We will go in the left side. So I think it will be left.
Left tail. Ah, okay. Left side. Okay. Okay.
So this is a left tail test. It is a one tail test, that is true. But what sort of one tail? Left tail. So
Left tail.
900.
Okay. Yeah, I didn't draw the. Yeah, that's I know where I made mistake.
Okay. So this is what we have. Then what is the mu value which we have? Mu is 1000. What is x bar? How much?
1010 1010, I think.
Then small n is 100. Small n is 100.
120, isn't it?
Yeah, yeah.
120.
100
And
was
standard deviation is 90.
standard deviation is 90. Alpha will be 0.01 only. So standard error for us is nothing but 90 divided by under root of 120. Yes. So under root of 120 is 8 point something. How much is this standard error value?
8.215.
Okay. So 8.215 is.
Yeah.
Okay. So standard error is 8.215. Fine. Now Z test value from the questions or from the data given to us in the question is how much? 1010 minus 1000 whole divided by 8.215.
Yeah.
So
It's
that
1
will be
1.217.
1.217. Okay. So this is the value of Z test from the data given to us. And this value is nothing but the value of H naught. Yes, this value is nothing but the value of H naught. Now what do we do? Just a second.
Compare with the table value.
So we will now calculate Z of 0.01. That means Z of whatever level of significance is given to us. That is something which we will calculate. So Z of 0.01 from the table we have to see. So let's go to the table once. So the level of significance or the level of alpha which we have is 0.01, this one, and value that we have calculated is how much? 1 point. So we will have to go to the next sheet.
1.21. So I went with the closest 1.2.
Correct, correct. So this is what we have to identify, 0.88686, correct. 0.88686. Right. So this is what we have. And now these two values are supposed to be utilized. When I say 0.88686, that means from here onwards, the rejection region shall start. So if I draw that diagram, this is your bell-shaped curve, something like this, right? Now, this is the 0th mark, and we are interested in 0.88. Let's say this is 0.88 mark. So from here onwards, the rejection region is supposed to start towards the left side. So towards the left side. That means this entire part of your graph is inside rejection region, right? This entire part of your graph is inside the rejection region. And what is the value of H naught that we have? It is 1.21. So is it lying inside the rejection region?
No, it's outside after 0.88. Yeah.
Correct. It's outside. That means it is somewhere here. It is 1.21. It's outside the rejection region. So can we reject the null hypothesis? The
Yes.
answer is no. No.
No.
It's not in the rejection
Sorry.
region.
Yeah.
It's not in the rejection region, so we
Yeah,
will
yeah.
not be able to reject it. So the inference which we make is, since it's not, is मतलब वो company जो है, the company which we have is not making false promises. It's authentic. So it's not is not lying in the rejection region. It's not is not lying in the rejection region, so we cannot reject it. Right? We cannot reject it's not. Okay, these two examples are clear. Any doubts? Two questions we have solved.
I'm good. I'm good.
Understood.
Satish?
Yeah, understood. I in the sense I understood what you're going through. I think I need to go back to the previous cases again to make sure I understood completely.
Okay, sure. So this is what Z test is. Now we shall get into how much time? 20 minutes. So what do you people want? Should we start with t-test, or t-test is comparatively easy? Just one property we have to look into. Otherwise, it's almost same as your z-test. Even the formula is same. X bar minus mu by standard error. Formula is also exactly same.
Yeah, maybe if you can just cover with one example in the next 10-15 minutes, is it possible? Or
We can give it a try. Maybe it might get
I don't know,
extended.
Satish, what do you think? I'm also asking Satish.
Yeah, Satish.
No, we can. Divakar said we can go with that one if you don't mind.
Yeah, just 10-15 minutes. If you just show us with one example, then
Yeah, it's pretty simple.
Yeah, at least we can finish it off t-test and start the other two tomorrow.
Yeah, sure.
Okay.
So in t-test, what happens is, as I told you, even the formula of t-test is exactly same as that of z-test. So formula wise also, both of them are same. So what is the difference? How will you identify if they are so similar to each other? How will you identify whether you are supposed to use t-test or z-test in the question? Very easy. In t-test, just one point you have to remember, that's it. Obviously, the table which you will refer will be different, that is true. But apart from that, one important property which you need to remember is that in t-test, the sample size will be very small. The sample size, or your small n, is very small. Now, when I say very small, it's a very vague statement. Very small means something less than 30. Less than 30.
When you say 30 in the sense.
Because right now, two examples we solved. In one of them, sample size was 120. In another one, it was 100. So sample size was comparatively huge. So if the sample size is huge, just understand that you are supposed to use z-test. If you find that no, the sample size is very small, let's say 15, 20, 25, something like that, something which is less than 30, then obviously you have to go ahead with t-test. As far as formula is concerned, it's same. So I'll just mention it here. T-test formula is exactly same. X bar minus mu whole divided by standard error. How to calculate standard error? Process exactly same. Okay. So formula wise, both of them are same. But when you look into the table, the T table, then you will realize that, okay, it has some point of difference. So two things you have to remember with respect to t-test. Obviously, the table which you are going to refer, that table will be different from that of Z table, and the sample size will be very small in case of t-test. If you have a sample size of 100, 200, then you use Z table, you use Z test. If you have sample size very small, 30, 20, 25, 10, then T test.
Okay. What if
T-test.
sample size is, sorry, Ashutosh, if it's 40 or 50? Z test or
Z test. Anything
Yeah,
more
okay.
than 30, even
30
31.
is great. Okay.
Even 31, you will use Z test. So let us now solve one question. Give me a second. I'll bring the question here. So it's a small topic, that's why we can cover it. Okay. So this is the question which we have. Now, just observe this question once. It says that a tire manufacturing company claims that the average life of a particular category of its tire is 18,000 kilometers. That means, what is this? Mu, right? When
Yeah.
we used normal driving conditions, a random sample of 16 tires. Can you see how small this sample is? How small this sample is? Small n is 16 only, which is obviously less than 30. So whenever you see such questions, where sample size is very small, whenever you see such kind of questions, immediately it should strike in your mind that because the sample size is very, very small, I am supposed to use what? T-test. Yeah. So sample size is 16. The mean and standard deviation of life of the tire in the sample were 20,000 kilometers. So this is what? X bar. Yes. This is
Yeah.
X bar. And this is standard deviation. So all these values are given to you. Assuming the life of the tire normally distributed, test the claim of the manufacturer at 1% level of significance. So alpha value is also given to you. Yes, alpha value is also given to you. So apparently, if you look at this question and if you are not aware of t-test, what will we do? We can directly apply z-test and we will get some result. Obviously, the result will be wrong, that is fine. But if you look at the pattern of the question that we have worked on the previous two examples and even this example, pattern is exactly same. The values you are having, you are supposed to develop H0 and H1, and then you are supposed to calculate the way you calculated Z test over there. Here you are supposed to calculate T test, and then further validation can be done using the T table, right? This is what we can do. So let us quickly solve this question. Process remains same. So even you people can assist me if you want. H0 will be how much? H0 will be
18,000.
So average life
H not equals, yeah, equals 18,000 kilometers.
and H1 will be opposite of it. Average life
Not equal to.
not equal to 18. So this is what? This is a two-tailed test. Yes.
Yeah, 0.33 is what it's getting. I'm not sure it's correct or not.
Which one?
Yeah, and when I calculate, I got a value of 0.33. I'm not sure if it's correct or wrong.
Achha, we'll see, we'll see. So H0 is this much, H1 is this much. Then mu given to us is 18,000. X bar given to us is 20,000. Standard deviation, how much? 6,000. And small n is 16. So standard error will be 6,000 by under root of 16. Yes, 6,000 by under root of 16. So what is the value? 6,000 by 4. How much do we have? 1,500. So standard error for us will be 1,500. Similarly, if I'm supposed to calculate t-test, that means value of t-test from the data given to us in the question, I will say it is nothing but 20,000 minus 18,000. 20,000 minus 18,000 by
Divided.
1,500. Yeah.
1500.
So this is 2,000. 2,000 by 1,500. That means 1.33. Yes, 1.33 you will have. So this is the value of what? T-test from the data given to us in the question. I have not done anything new. Exactly same process which we used to follow in case of Z-test. Same thing I have done. Nothing new. No. Till here things are fine. Any doubts?
Yep, clear.
Yeah, I'm good.
Okay. So till here we have understood how the things are working. Now guys, because it is a two-tailed test, what we will do? We will take alpha by 2 value, isn't
Yeah.
it?
Yeah.
Alpha by 2 value. That means what is alpha? 1%. Matlab 0.01. So 0.01 divided by 2. That means 0.001
1.
divided by 2.
5, sorry, 5. Yeah.
So 0.005. This is the value of alpha that we need to consider. That means we have calculated the value of t-test, that is equal to 1.33. That is fine. Now we have to calculate t of 0.005. This is what we have to calculate, t of 0.005. Yes, 0.005. Let's go to the table. Let's search for t table first. T table. T table. Okay, so this is your t table. Acha. Here, one more new concept will come to your notice before I show you the table. There is something called degree of freedom. How do you read a t table? That is something which you will understand right now. How do you read a t table? In case of Z table, it was very simple. In case of t table also, it's simple. On the x-axis, same. Alpha values you will have. Okay. So for us, alpha is how much? 0.005 because we are making a divide. So we are dividing it by 2. So alpha is 0.05. We will search for that value in the x-axis. And importantly, on the y-axis, what are we searching for? On the y-axis, we are searching for something called degree of freedom. We are searching for something called degree of freedom. What is degree of freedom? I'll just write it down here. Let me write it down here. Degree of freedom is nothing but small n minus 1. So for us, what is small n? 16 minus 1, 15. So for us, degree of freedom is 15. So on the y-axis, you will search for degree of freedom, specifically how much? 15. So 15 is degree of freedom, alpha is 0.05. Sorry, 0.005. So alpha is 0.005. 0.05. Can you see this? Alpha is 0.05, 0.005. Sorry, ये वाला होगा. This one. 0.
Yeah, that one, yeah.
This one 0.005, and
So it's
here degree of freedom is 15.
2.947, I think.
2.947, correct. 2.947.
947, correct.
So p value from the table is 2.947. So what is this? H naught value. What is this? The point from where your rejection starts. And this is two-tailed test. That means you will have rejection region on both the sides, isn't it? You will have rejection region on both the sides. That is what we have observed. So if I'm drawing the graph here, okay. So 2.947 is the place from where your rejection starts. So let's say this is 2.947, 2.947 on the left side, sorry, on the right side, and on the right side also minus 2.947. So both positive sense and negative sense we will derive from here only. So when it says 2.947, it is considering negative value and positive both. So on both the sides, this kind of rejection region is created. Okay, the rejection region on both the sides, they are created. And for us, what is the value of alpha? Sorry, what is the value of H naught?
1.33.
1.33. So it will be somewhere here, 1.33. That means it is safe. It is not falling in the rejection region, because rejection region starts from where? From here. This is your rejection region. This is your rejection region. So we are not falling into the rejection region either on the left side or on the right side. So what we will find, because we are not part of the rejection region, that's why we are not going to reject H naught. That means whatever claim the company is making, with respect to 18,000 kilometers and all, that is all true. Okay, that is all true. The claim of the company is correct because the value of H naught is not falling in the rejection region. It means we cannot reject H naught. Fine.
Yep.
This is how you solve questions with respect to t-test. Almost similar. The only point is degree of freedom, something new, and obviously sample size. Okay, so today we have been able to complete Z-test and t-test. Tomorrow, first of all, we will complete ANOVA because that is more important. So first of all, we will complete ANOVA, and if time permits, then I will talk about chi-square test. If time does not permit, no problem, we shall continue that. It won't take more than half an hour. So half an hour we shall dedicate on Tuesday to complete chi-square test dedicatedly. But tomorrow, main emphasis will be on ANOVA. Okay.
Okay, sure.
Yeah, okay.
So let's keep it till here for today. Tomorrow we shall continue.
Yeah, okay. All right. Thanks, Ashutosh. Thanks, Satish. Take care, mate. Yeah, keep warm.
Thank you, buddy. Thank you, Ashutosh. Thank you, Divaka. Take care. Bye.
Yeah, thank you.
Bye.
Bye.
Bye.